evaluate cube roots and square roots. Think about this question during the lesson. Alberto is building a birdhouse for purple martins, birds that prefer cube-shaped birdhouses. Alberto wants to know the dimensions of each square piece of wood he needs to build the 125 cubic inch birdhouse. What do you know about the length, width, and height of the birdhouse? The length, width, and height of a cube are all equal. We can draw and label this cube to represent the birdhouse. Alberto needs a volume of 125 cubic inches. The length, width, and height are all equal. We'll label the sides S. The volume is equal to S times S times S, or S cubed. A number that is a cube of an integer is a perfect cube. The number 125 is also a perfect cube. Which of the following is also a perfect cube?
Select your answer.
This symbol means the cube root of a number. The cube root of 125 is equal to the cube root of 5 times 5 times 5, which equals the cube root of 5 cubed. Taking the cube root and cubing a number are inverse operations. So the cube root of 5 cubed is equal to 5. The dimensions of each square piece of wood are 5 inches by 5 inches. Are there other dimensions that would give a volume of 125 cubic inches? If so, are they answers to this problem? There are other dimensions of a rectangular prism that give a volume of 125 cubic inches. However, only one set of dimensions makes a cube. So there is only one answer to this problem.
A cube-shaped art sculpture has a volume of 64 cubic feet. What is the length of each edge of the cube?
To find our cube, we're going to take the 64 and we're going to find the prime factors. So we know that 8 times 8 is 64. And we know 4 times 2 is 8. We know 2 times 2 is 4, and 2 times 2 is 4. So we have now I'm going to circle my prime numbers. I have 2, 2, 2, 2, 2, and 2. So I'm going to write this on the side here. This is a way that this method I'm using is a way you can find the cube root of any number, not just 64. So we have 1, 2, 3, 4, 5, 6. So you would rewrite it as 2 times 2 times 2 times 2 times 2 times 2. All right, 1, 2, 3, 4, 5, 6. Okay, so now you take your prime numbers and then you circle, because we're looking for a cube root, you're going to circle the same number in groups of 3. So there's 3. There's 3 2s here. And then there's 3 2s here. So when that happens, we can pull it out from under this the root sign. So we have 2 and times 2. and then you multiply those together and you get 4. So I know my cube root for 64 is 4. Now I'm going to go backwards. And now I would know that 4 cubed would equal 3, which is the same as 4 times 4 times 4. And if you want to check yourself, 4 times 4 is 8. And then 8 times 4 is 32. That's what I get for rushing. 4 times 4 is not 8. 4 times 4 is 16. And then 16 times 4 is 64. So 4 is our cube root of 4. So that would be 4 feet.
Plot, compare, and order the cube root of 64, the square root of 100, the square root of 49, the cube root of 8.
First, you would have to find or evaluate the square and cube roots of each number. So they've done that for us. And then you can order them. Plot, compare, and order them. So we're going to plot, and then they use the number line and they plotted it by using the original value on top of the number line and the value that it equals. And then that's it. And then comparing them is using the greater than less than symbol, so they have it from least to greatest.
Plot, compare, and order the values of the expressions. 2 and 9/10 plus the square root of 25. 2 squared plus 1/2 minus the cube root of negative 27. The cube root of 64 times 1 and 9/10. 32 and 8/10 divided by the square root of the quantity 2 cubed plus 8.
First, you evaluate each expression. So here's the first one. You evaluate first by finding the square root, so you have one value. That's 5. So you have 29 plus 5. That's the first one. Then you have 2 squared plus 1/2 minus the cube root of negative 27. So here you have that broken down here. You find the cube root, negative 3. And then you have 2 squared, it's 4, plus 1/2, minus came from here, and that's negative 3. And then you add that up, you get 7.5. Then you have your cube root of 64 times 1 and 9/10, and then you get that. And you solve this last expression, and you get that. Then you plot them on a number line and order them just like you did in the previous example. Now we would do the same here, compare and order this time. So we're going to find the value of each of the values. So the cube root of 125. I'm just going to take the 125. I'm going to find the prime. So 5 times 25 is 125. Then 5 times 5 is 25. So this happens to be a perfect cube. So I'm just going to circle our prime numbers. And so the cube root of that is going to be 5. Now we have the square root of 225. And so again, we can do the same thing. 225, we find the prime. So we can use prime is 5. Okay, so we have 5 45. Then we have 5 times 9. Then we have 3 and 3. So here's prime factors. And then we pull those out in groups of 2. So we have, let me use a different color. We have 5 and 3. So for this one, 5 times 3 is 15. So 15 is the square root of 225. And then we have negative 1 squared. So negative 1 times negative 1 is 1. So we're going to make that on. So that's going to be a 1. And then we have the square root of 1 and 96/100 times 10 squared. So first, 10 squared is 10 times 10. That's 100. And then you have 1 and 96, supposed to be a 9, 96/100 times 100. What is that equal? 196. So now we have the square root of 196. And so we will find the factors of 196. So let's see, we'll use 2. So 2 times 98, and then 98 and 49. 2 times 49, and then 7 times 7 is 49. That's 7 times 7. And so our prime numbers here are 2, 2, 7, and 7. So groups of 2, we have 2 and 7. That equals 14. So the square root would be 14 of that expression. And then last but not least, we have the cube root of negative 125. So we already found the cube root of 125 in the first expression. So it's going to be the same, which is 5, but this time it will be negative 5. So I'm going to write each of these on the side here. So we have 5, 15, 14, and negative 5. Now, it asks us to compare and then order. So from least to greatest, let's do that. From least to greatest would be negative 5, 5. Oh, I'm going to make that a positive 5. Okay, 5, and then 14, 15. And if we wanted to compare them, we just would add the greater than, less than, and greater than symbol. So I'm just going to use a different color and put the symbol right in between each. And that's how you would compare and order them.